Okay, now we have moved to the calculator section of the 3.1 to 3.2 review, and with number 7 we actually are going to need our calculators. If we read the expression or the instructions, it says we want to write the equations of the lines that are tangent to this graph at the point where the derivative is given to us. So this is a little tricky. The goal is we want to write equations of lines. And remember, to write equations of lines, we need a point and we need a slope. And the slope is the derivative evaluated at the point. So in this particular case, we don't know what the point is, but we do know that the derivative needs to equal 1. So in order to find the point, we are going to take the derivative and set it equal to 1, and then use our calculator to find out when that occurs. So what I'm going to do is I'm going to put y1 into my calculator as 3x to the 4th plus 5x squared plus 4. So I'm going to do that off screen here until we actually need to see what I'm doing. So 3x to the 4th plus 5x squared plus 4. So I've got my y1 stored in there. The reason I did that is that I'm going to need the y coordinate once I find my x. So to begin with, let's take the derivative. F prime of x will be 12x cubed plus 10x plus 0. So I need this to equal 1. So on my calculator, I'm going to solve for when 12x cubed plus 10x equals 1, and I'm going to solve that with respect to x. So now my calculator comes into play. I'll scoot this over here. So I'm going to go to my home screen. Remember, solve is under F2. So I'm going to solve for when that 12x cubed plus 10x equals 1 with respect to x. Now when I hit enter, I'm going to get this big long decimal, and it's going to take some time to work for me. And I can see here that I have x equals 0.09884, on and on and on. So in this case, we're going to want to be able to use this x coordinate to generate the y coordinate, because our goal is to get the point and the slope so that we can write the equation of the line. So here we've got our x coordinate. I can write that down. 0 point, and remember we always want things correct to 3 decimal places, so 0.099. This is what I'm going to write down. However, on my calculator, I don't want to round too early. I don't want to plug this rounded variation into f. I actually want to use as many decimals as I've got. So my calculator can actually facilitate that for me, because I stored my function in y1. All I need to do is plug this number into y1, and both of these things are already in my calculator. So to get that y coordinate out, I'm going to type y1 of x, and then I will evaluate. Remember that straight up and down button that's below your equal sign? I'm going to evaluate it when x equals this number. So to get that number, I will go up and turn it black and hit enter. Now I'm going to be plugging that value of x into my function that I stored in y1. So if I hit enter now, that's now my y coordinate. So y equals 4.0401. Again, I need 3 decimal accuracy, so I will write down my y coordinate is 4.040. And then I'm going to create the equation of the line. So the equation of the line is y equals my slope times x minus my x coordinate plus my y coordinate. Now in the review, I have left my answers written in this point slope form. On the test, I will convert it to slope-intercept form. So that means I'm going to distribute and combine everything. So I will distribute the 1, and then I will get it in slope-intercept form. Oops, forgot my x. So I'll have an x minus, okay, so now let's see how we can do this on our calculator without compromising accuracy. Here's my x-coordinate, here's that y-coordinate. Notice the x-coordinate got multiplied by a 1 and it was negative, and then I added that. So I can just clear this, take this one, and add the opposite of x, oops, when x equals that number. Then I don't have to type in all the numbers and risk transposing things. So we can see that I get a x plus a 3.950. So this is the answer that would show up on the exam. Oh, my light is just a little bright. Okay, so part B works exactly the same way, and notice that the function doesn't change. So all I'm doing is altering the slope, which means I'm going to be solving for when that slope equals a different number. So for part B, same process. I guess we can fit this on here. Same process with B. We still need that point, and we need that slope. The slope in this case is 2. Now we're going to go find that x-coordinate and that y-coordinate, and then we're going to create the slope. So because we need that slope to be 2, that means I'm going to be solving for when that derivative, which we found up here, is 2, and we're solving with respect to x. So that's going to give me my solution for the x-coordinate. So again, I've got my solve. If I arrow up here, we can find that old solve equation that I used in part A. So I'm going to do this exact same thing, except I'm going to backtrack and make that a solve when x equals 2. I'll hit enter. There's my x-coordinate, 0.19156. Then I need the y-coordinate, and the y-coordinate means I'm going to plug this x-coordinate into the y editor. So y1 of x evaluated, go up, grab that x, turn it black, and hit enter. That will put it on your little home entry panel. Hit enter. Here comes my y-coordinate, which is 4.1875. So now if I want to write the equation of the line, I can write y equals the slope times x minus the x-coordinate plus the y-coordinate. Again, on the test, I will probably multiply this all out and get it in slope-intercept form. So I'll have y equals 2x. Then on the home screen, I'm going to do a -2 times that x value plus the y value that I just found. So I'm going to turn that black. So there's my y value. Then I'll evaluate when x equals this number. So hit enter. I get a 3.804. So that's what would show up on the test. Now, these are similar enough. I'm not going to do C and D. That's kind of a waste of your time. I doubt anybody would watch beyond part B.